Hello project people, welcome to the CPM and Pert full course with solve example. In this course, we are going to learn about the concept of CPM and Pert with solve examples. First, we will learn about what is a CPM and then what's the concept of Pert. After learning about the concept of Pert and CPM, we will deep dive into how to draw a network of CPM. Once we understand how to draw the CPM network, then we will do the forward pass and backward pass analysis to find out the durations, and utilizing the duration we will be finding out what is your critical path, and then accordingly we will see what's the project duration. And also after learning the basic concept, we will deep dive with several solve examples which will help you to solve your exam problem, as well as which will give you a detailed understanding how these tools and techniques work on your project. After learning about this basic concept, we will deep dive into how these techniques are used in professional world for managing project, as well as we will learn into the various pros and cons of the CPM and Pert network. So, do you know how CPM and Pert started? What is the history behind the CPM and Pert technique, and why they were actually utilized to solve the various problems? So, CPM is basically your critical path method, right? This is what it means. What's the full form of the CPM? Also, it is known as CPA, which is basically critical path analysis, right? And if we talk in terms of definition, what exactly it is, so it's basically a simple and powerful technique which is used to analyze and planning and scheduling the complex project, right? This is how it is utilized for analyzing, for planning and scheduling complex project. And this is one of the most important concept in a project management, and you will know why we are talking it as most important, because the CPM is basically analyzing your various activity in a project, and project is nothing but a combination of various sets of activity which need to be performed under certain duration, right? Because project completion has some target date, and you need to do those project activity under certain given timeline so that you can complete the overall project on time. And that's why it's become very important to understand the each activity duration, which are the critical activity, and how much time the overall project going to take, so that you can manage, or you can focus on the critical activity to manage the overall project and reach its objective. So if you talk about the history of project management and the CPM, so it's all started at Manhattan Project, right? Remember, Manhattan Project was utilized to develop the A-bomb, and which basically ended in World War II. And this was a time when CPM technique was first utilized to develop the atomic bomb in Manhattan Project, and which was like early 1940s. And after their war, these techniques were utilized in various industrial and others, the sectors, to get the benefit of the CPM technique and do their projects more efficiently, and get the benefit of the out of utilization, analyzing and planning through the CPM techniques. So if you talk about the PERT, so PERT is basically a program evaluation and review technique. This is what the full form of PERT is, and it's a statistical tool, right, which is utilized in project management to analyze and represent the tasks involved in the completion of the project. So it's used, the statistics means basically it's used some probability factor or probability distribution to understand the activity durations, what could be the possibility of completion of those activity, and then what will be the overall possibility of completing a project. We will be learning these concepts in detail, but basically on a higher level you can understand that it was developed basically to simplify the planning and scheduling of the large and complex project, because once a project is large and complex, of course the duration of each activity also become very difficult to estimate and find out how much time each activity is going to take, given so many complexity, so many factors which is impacting your project's outcome. So if we talk about the history of PERT, it's all started in 1957 with Navy Polaris nuclear submarine project. Remember? So in 1940s we developed CPM, Then in 1957, it was utilized for Navy special project, which was to develop your Polaris submarine project, right? And this is where your PERT techniques was being utilized first time for a project, and after that this PERT was utilized for other commercial projects and various industry by seeing its benefit. So once you understand the concept of CPM and what was the history behind the development of CPM technique, let's start our journey to understand the CPM technique itself. So what is CPM? Well, if you talk in terms of definition, the CPM is basically a step-by-step guide for project management technique for planning. Basically, this CPM related to planning, which defines your critical and non-critical tasks. Remember, every project has some critical and non-critical tasks. It doesn't necessarily mean when you do a project, then all the activities are critical and you have to do all that activity at the same time or with the same focus, right? It's a mixture of critical and non-critical activity, and you need to plan those activity or you need to sequence those activity in such a way that you reach the goal of the objective, and by solving the various problems which you occur or various bottleneck which you notice while project is getting completed. Okay, so basically it's a step-by-step project management techniques for the process planning, which is basically defines the critical non-critical task to reach the goal by preventing the various schedule problem and the bottlenecks, right? So this is what the definition you can refer as a critical path method, right? So as I mentioned earlier, project is basically your combination of critical and non-critical tasks, right? So at any point of time, if you want to know or if someone asks from you that how long the project takes to complete this activity or the complete overall project by meeting the objective, what are the most important activity which you should be focusing, right? How do you identify which are the critical activity and which are the activity which you can do not focus much, but you can adjust those activity, in simple terms. So the process of identifying those critical activity, basically you mapping out those tasks and their duration, which can help you to get the reasonable estimate of the project timeline, as well as this timeline key information will help you to find out what will be the project cost and the budget requirement. So in brief, critical path method is basically used to determine the project's path, which is important for completion of the project, and usually it's the longest sequence of the task which has to be finished so that your project is completed on time by meeting all the objectives. So let me explain this with a simple example. Let's say you want to make a chicken sandwich at your home, and this is just a mini project for you. Okay, so now to make chicken, to make this sandwich, you will need basically some ingredients like butter, chicken, vegetable, cheese, depending upon your taste or how you want to make it, right? But still, whatever sandwich you make, there are some key ingredient which you will be required irrespective of what type of sandwich you are making. So let's say your bread is a key element, right? And you have to have the bread so that you make your sandwich. Maybe some vegetables or some uh, lettuce or those kind of leafy vegetables may be required to make the sandwich. Without that, your sandwich is not complete. So there are some key ingredients, or getting those ingredients is basically a key activity if you consider this one as a project, and those are the critical for the completion of the project. So similarly, in a real world project, there are some key activities for every associated projects which has to be completed. You need to identify what are those critical activities and what is the duration of those activity, and those are the activity which fall basically the longest sequence or longest duration path of the project. And this is what CPM does in a the analytical way to understand what are those activity, what is the duration of those activity, and how much time is going to take, right? So every project, right, whatever project you take on, regardless of its budget, size, which industry it is, they have some core task, right, some important task which is crucial to its completion. And the CPM goal is to understand what are those tasks and find out the detail, and so that you can focus on those tasks, right? And if you talk in terms of definition, when do we call a task is critical? So critical means if you delay that activity or that task, that will basically delay the overall completion of the project. This is what is meant by the critical. It means you cannot delay those activity until unless you want to delay the completion of the overall project, and that's why we always call them critical. Okay, this is what's mean of the critical, because if you delay those critical activity, your project is going to get delayed. So after learning about the basic concept of CPM technique, let's understand how to draw the CPM network, and then we will be utilizing that network to calculate our various project activity duration. Okay, so let's solve a problem of critical path method. And if you see in this question, basically there are three parts. First thing is you need to draw a CPM network itself. Then you need to determine the critical path and the project completion time, as well as then you need to compute the total float and free float for the non-critical activity. So these are the question we need to solve, and the information which is given to us is basically your the activity list, what are the activity for the project, and then what is your immediate predecessor, basically up to which or from after which activity this activity is going to start, and then what will be the duration of the activity itself, right? So basically there are three columns, and this gives you the list of A to N, right? These are the list of the activities, and this gives you the list of those activities which are the predecessors, right? So before jumping into drawing the network itself, getting into the detail of the CPM network itself, let's first understand what information is given, right? When I say what information is given, we need to understand what does this actually mean by A, and then in predecessor it's blank, then in some activity is given one activity, and then in other activity we see some two or three activity. What exactly does it mean in terms of when you visualize your CPM network, right? So that's very critical, because if you don't understand correctly, then while drawing the CPM network you may face issue, right? So let's start with our first activity. So if you see the activity A, B and C, right, for these activities we don't have any predecessors. It means this activity can start immediately. They don't wait for another activity, because there is no other activity which is required to be completed, right? So it means that from the node 1 that we draw in the network, from there itself all those three activities are going to start. So these are basically called your starting activity, right? These are your starting activity, and they will start from single node, right? And that is your node 1. That's the one critical information. Then if you go and see the activity D is going to start when B is finished, right? And then you have the activity E. Activity E is going to start when your A is finished, and activity F is going to start when A you're finished. Now here if you see, for E and F we have the same activity has to be finished. It means there will be a node in our critical path network diagram where E and F are going to start from the same node, right? That's the one critical information, and that will be the node where your activity A is finishing. Then you have the activity G. Activity G is going to start where the B is finished, right? And it's independent single activity. Then you have the activity H, which is going to start with a node where C and D activity are finishing. It means in your CPM network there has to be a node where C and D are converging, right? Where C and D are converging, it has to be a node. We'll see how we will try. And then from that node your H is going to start. Then for activity I, again it is originating from C and D. So basically from activity C, let's say this is C and D activity which is converging to this node. From this node your H is also going to start and I is also going to start. Okay, so it means that in your network there has to be a converging node, a converging point where C and D are finishing, and from that converging node your H and I are starting. Okay, then you have the J has predecessor of E. It means J will start where E is going to end. Okay, similarly for K, if you see K, we have a node which is FGH. It means your K activity will start from a node where F and G are finishing. It means that you have to have a node in your the CPM network diagram where F, G and H, right, all these activities are converging at same node, right, and from that node your K will start. Okay, similarly your L is going to start from FGH network. It means that if this was a FGH node where they're converging, then your L is going to start from the same node, right? And then your M is again going to start with I, right? So you need to start where the I is finishing. From there you will start your activity M, and then you have the activity N, right? Now in activity N you say the J and K, so it means your activity N is going to start with a node where J and K are converging, right? So a node where J and K, right, J and K activity are going to converge. You have to basically start from here activity N. Okay, so these are very the critical thing. So keep this point in your mind when you start or before drawing your network diagram, otherwise you will get confused. Then another thing, if you see for J, L and M, sorry, L, M and N, right, these activities are ending activities, right? Why I'm saying that, and how do I know this is will be ending activity? Because if you see in the predecessor list of predecessor, you can see A, you can see B, you can see C, D, E, F, G, H, I, J, K. So till here all those activities are listed in predecessor. It means up to activity K, those activities are somehow related to the previous activity, but L, M and N are not mentioned somewhere in predecessor. It means these all three activities are ending activity, and these all activities are going to end. So your last node of your network diagram, right, let's say this is your last node, your last node should have this kind of convergence of L, M and N. Okay, so we know how where to start. We will be starting with a node where A and B, C are starting. We will be finishing with a node where L and M are ending, and then in between we have these kind of networks. Okay, so this is how you need to read your question when you see your CPM network question in your exam. Mostly this is required for student, because in professional life there are already software designed to do this kind of complex calculations. But for student point of view, this is the this is the approach you should be following to do CPM network exam question in your exam correctly, right? So now after understanding this, the question itself, the information which we have, now let's start drawing the CPM network. Okay, and then we will utilize all those information which we have gathered from the question, and we come up with our CPM network, right? And this is what your first task is. This is our first question, right? We need to construct a Okay, so now let's start drawing our CPM network, right? I have kept this the information from the previous question so that we can quickly refer this. So remember, we have to start with the activity A and then finish till the activity N, and make sure those all are in CPM network diagram by following this logics, right? This is basically nothing but the logic which you need to follow while drawing your CPM network. Okay, so let's start with first node, and I will be mentioning the nodes at node n1, n2, n3, so that we don't get confused with these numbers, with and the duration which we will be mentioning on our network. So let's start with node 1. So I will be taking the node 1 as our first node. Okay, so let's say this is our first node. Now if we go to the first activity is A should immediately start because there is no predecessor. So let's start our activity A. Okay, I'm just making this arrow, right? And let's say this is our node 2. Okay, and this is our activity A. I'm not mentioning the duration now, but we can mention later. So let's just keep it simple for the timing. So we have node 1, which is starting node, and we have drawn our activity A, and this is ending to node 2. Now similarly, we need to start our activity B also because it doesn't have any predecessor. So let's say this is our B activity. Okay, and let's say we name it node 3, right? Then similarly for activity C, there is no predecessor, so we'll start our activity C and we'll mention it as, let's say, node 4. Okay, and this is our activity C. So we have drawn our activity A, activity B, and activity C. Now we have the activity D, right? Now if you see activity D, it should start with B, where the B is finishing. So B is finishing here. But if you see, D is also predecessor for H activity and then I activity, right? Because when you say, if you just look at this row, right, it simply says that D should start after B, right? So you can simply draw a node here and just mention it as a D, but that will be wrong. Why? Because there is another condition, which is C and D should converge together, right, at some point of your network. Remember, we have discussed in our previous session that C and D should be converging at a single node. It means you have already drawn the C, which is converging at N4, and B, which is ending here. So obviously your D should be like this, which is starting where B is ending and then finishing where C is converging. So it is basically complying this rule of convergence of C and D, right? So it should be like this. It should not be like this, right? The D, that's a wrong path. So this is how you need to follow the that's why we were discussing earlier about this logic. So we have drawn the D, right? D is completed. Now let's come back to the E. Now E is again starting with A. Now if you see here, E is also predecessor of J, right? But again, this is a single activity. There is no other converging activity. It means we can simply keep on drawing E activity after A. So let's draw our activity E. Okay, and then let's call it this N5. Okay, this is node 5, and again it there's no other converging activity at this point of this node, so we just mention it E here. So we have drawn E, and then remember F is also starting from A, where A is ending. So remember, A is ending where E started. Now we need to draw another activity, which is your F. Okay, and F is basically, let's say this is node 6. Okay, so we got node 6, which is basically for F, and then we node N5 for E. So we have drawn this node also, right? And this basically covers your this criteria of starting from a node where A is finishing. Then you will come to the G. Now G is your starting from B, right? But if you see, G is also has to be a converging point for I mean, G has to finish. So we know from where it will start. It will start from here, that's for sure, right? Because here B is ending. But where it will end? It will end at a point where F and G and H are converging, right? So there has to be a node. There has to be a node where F, G and H are converging. So remember, we have already drawn a point where F is converging at N6. It means it means we need to draw G in a such a way that it converges at node 6. So it means this will go here and this path is your G. Okay, this is your G, which is starting from B and converging at N6 because F is already converging at that point. Okay, so we have drawn G. Now let's come back to H. Okay, now H is starting from a point C and D. Okay, fine. So we have this point already ready there. So we'll start this H, and then if you see F, G and H are converging at same point, and this is basically nothing but N6. So it will start from here. It will start from C and D and converge it here because remember we have a condition of F and GH converging at same point. Okay, so this will be your basically activity H. Okay, and then it's going to converge at this point. After that we have drawn H also, right? Let's draw this I. I is basically your C and D, so starting from this point, but again the I is the predecessor of M also, so we need to see we need to draw when we are drawing this M, we need to make sure M is starting from the I. So for the timing, let's draw another activity I, which is starting from C and D where they are converging, right? And I will just call it, let's say N7, node 7, and we call it I. Okay, so I is also drawn. Then we have another activity is J. Okay, now where is your J? The J should start from E, where E is ending. So E is ending at node 5, so we will just simply draw a node which is J. Okay, and the J is basically a independent activity. Now if you see here, we have the activity J and K should converge at some point because we need to draw activity N. Keep this in mind, right? So, and that is your K now. So from K should start from FGH, which is we are having a node of N6. Okay, so it should start from here, and where it should end? It should end a point, remember, where J and K are converging. So remember we have drawn this J, and it should basically converge at this node because J is ending here, and let's name it as N8. Okay, this is node 8 where K, J and K are converging, right? And K is basically starting from this point, which is F, G, H, and then it is converging at a point where J and K are converging. Okay, so we have drawn our K also. Now the ending activities, remember these are the ending activities because they are not somewhere as a predecessor. Okay, so these are the ending activity. It means these all activity J, K and N has to converge, right? Now for L activity, right? L is basically starting from your this and then converging to which point, right? Node N. So let's draw a node N, right? So from here up to K and starting with FGH. So I will take this node and let me put this node as N9. Okay, and this node is basically nothing but your denoting activity L. Okay, now we have the activity M which start from I. So remember I is finishing node 7 and it's the last activity, then it should basically converge here, and which donates our M. Okay, then our activity N, right? So N is basically starting from a point where J and K converging, so which is N8, and obviously we should go to our last node 9, which is this is our last node. Okay, so this is our last node and this represents your activity N. Okay, so this is how you need to draw the CPM network by learning or by utilizing your immediate predecessor information, so that your network, whatever you're drawing, is following this logic, right? Remember, if your logic is not correct, your CPM network will not give you the right answer. So it's very important to logically draw your CPM network, and this is how you should be drawing your CPM network. So once we draw this network, we will be coming to the next step, which is basically assigning the duration and then finding the total what's the critical path, and then the float and all those other informations. So this is the first step for drawing your CPM network. So in previous session we have basically learned how to draw a CPM network, right? Now if you see our question, so the first task was to draw a CPM network, which we have already did in our next session, the previous session. Now the next question is that we need to determine the critical path, right? And then we need to determine the project completion time. So there's a two information which is required to gather from the the network which we have drawn. So let's understand how to find this the critical path, and then what is the duration of your project. So once you understand the concept of CPM network and how to draw those network by utilizing the various logics which is given in the activity, next step is to do the forward pass and backward pass calculation. By doing this forward pass and backward pass calculation, we are going to find out the duration of early start and late completion. So let's find out how to do it. So if you see in this slide, so this is the network which we have drawn earlier, right? So now if you see in this network, I have added the durations, right? These are that all marked in green are basically all durations which we had, so which we were having from the question. So this was given in the question. I just brought it against each activity as a duration. Now we need to calculate the critical path for those network. So to calculate the critical path, we need to first understand for each node we will be calculating two information. One is how early activity can start and how late it can be finished, right? That's why if you see here, I have basically made these two boxes, right, at each node, and this is basically representing the upper portion. I will be calculating your early start, means when an activity can start early, how early that activity can start. And then the next one is your late completion, how late that activity can start, right? So the value which you will be calculating through this early start is known as basically forward path, right? And if you calculate with the late completion, that is called your backward pass. So first we will calculate this value for the upper half, that is your forward pass, and then later on we will calculate the late completion, and by using those two information we will be basically calculating a critical path, right? So here if you see if the network itself, so you can follow various paths. You can start from node 1, go to node 2, then go to node 6, and then from 6 to n, and then to node 8. Like this you can follow from 1 to n3 to n4 to n6 and n8 and n9, or you can simply take the path from n1 n3 to n4 n7 and n9. So there are several paths in this network, right? Now the point is that how to identify which is a critical path among those networks. So that's what we are going to learn in our next slide. So we'll start calculating our forward pass calculation with utilizing the same network. So I will start with node 1. Node 1, the node 1 always start with 0. Remember this thing, right? So to start, the early start of this node 1 is 0 because you can immediately start that node. There is no predecessor activity for this, so you don't need to wait for another activity. You can, as soon as you decide, you can simply start this. So basically it means that it's a 0. It's a baseline, or the starting time for this is 0, and in network method we always consider this as a 0 starting point, right? So now suppose if you want to complete the activity A, let's follow this path from n1 to n2, and if you want to complete this activity, the earliest you can finish this activity will be your 0 plus 2 days. Let's say this is 2 days, so it will take 2 days in total to complete this activity, right? And this is what you become 2 days as your early start, right, for this node. Now if we move to the next path, let's say for E, from node 1, node 2 to node 5, and if you want to complete this activity as early as possible, that will be basically 2, which we have taken from n1 to n2, and then 2 which will be required to complete this activity A, and then you need to add the duration of E. So 2 plus 7, it's 9. So basically you can complete this activity E in 9 days, because remember, to complete E you need to have your activity A completed. So that's why we need to add 2 plus 7, and that's becoming 9. That's the early start for your activity E. Now if you follow this path for activity B, so you see here early start for node 1 is 0. Node N3, the early start will be basically nothing but 0 plus 5. 5 is the duration for the activity B, right? So that's why we are taking 5. So this will become your 5. So it means your early start is 5, right? Now let's complete complete the node N4 also. So similarly for C also it will be 0, starting is 0, and then duration for C activity is 4. So 0 plus 4 is 4. It means here it should be 4. No, because remember at node 4 there are two paths are converging, right? And at N2 there was 1, at N5 there was 1, so we straight away added. But here if you see this path, in this path there's two nodes are converging. One is coming from N1 to N4, another one is coming from N3 to N4. Okay, so first we need to calculate the early start for this one. So to calculate this one for this path, right, from N1 to N3 to N4, we need to basically add the durations. Now to for N4, by following this path, you need to basically add 5, which was early start of for this path, plus the duration of this activity D, which is your 5. So 5 plus 5 equal to 10. Okay, so you will be now to at this node, if you follow the node N1 to N4, your early start will be 4, right? And if you follow this path N1 to N3 to N4, your early start is 10. Now which one to choose out of these two? So remember, for forward pass we always take maximum, right? So maximum early state duration is basically going to the early start for the particular node. So in 10 and 4 the maximum is your 10, so we will take 10, not 4, right? So we found this early start for this node 4. Now let's move to the next nodes. Okay, so if you see here, let's say we have already completed N1, N2, N3, N4. Let's move to N6, right? Now at N6 you will see there are 3 rows are converging, so 3 arrows are coming, right? So basically one is N2 to N6, one is N3 to N6, another one is N4 to N6, right? So there are 3 paths. So let's calculate for first N3 to N6. So remember we had only add to this node, our earliest start is 5. Now to complete this node, if we follow this one, it should be, as per this path, it should be your 5 plus, remember this is activity G, so 5 plus 3 equal to 8, right? But remember we have another path also, N2 to N6. So for this one, remember we have the 2 is early start, 3 is the duration, so 2 plus 3 equal to 5. And then there's another path from N4 to N6. Remember at N4 we had early start of 10, the duration is 6, so the early start of this should be your 16. So now we have 3 options, one is 5, 8 and 16. So at this node the early start duration should be your maximum of this 5, 6, 8, which is your 16, right? So now we found the early start of node 6 also. Now let's find the early start for this node 7. So if you see at this node we calculated 10 as our early start. Now if you move forward along this path, the duration is 2, so it should be 10 plus 2 equal to 12, and remember there is only one incoming arrow, so it's just 12 will be your early start. Okay, so we calculated this one. Now moving to this node. Now this node again, if you see here, it's basically converging with 2 paths. one is n5 to n8, right? N5 to n8, and then another one is n6 to n8. So if we calculate the early start for this path, so remember we have previously calculated 9, so 9 as early start till that n5, plus we will add this duration, so 9 plus 5 equal to 14. Now if you follow this path, n6 to n8, it should be basically your, remember we have calculated early start is 16, so 16 plus 4, that's 20. Okay, so out of 20 and out of 14 and 20, the max is 20, so 20 is your early start here. Okay, now let's move to the next node, that is your last node, n9. Now at n9 you see there three paths are converging. Okay, one is n8 to n9, another one is n6 to n9, and n7 to n9. Now we need to calculate the early start for all three and then take the maximum for all three, right? So this is what we are going to do. So remember till n8 we have calculated 20, and the duration for n is 8, so 20 plus 8 is your 28. For this path, if you see that it's coming from n6, for n6 this is ES is your 16, so 16 plus 3 is your duration, so as per this path it is 19. Now as per path which is n7 to n9, if you see the early start was 12 till this path, so 12, and duration of this one is 12, so which is 24. So now we have three option, one is 28, 19 and 24. So for node 9 it should be 28, because 28 the maximum. Okay, so this is what is forward pass, right? So we start calculating early start for each node, and then you arrive at the last node, which is your 28. Okay, now we will be calculating the backward pass, and then we will be finding our critical path. Okay, so in previous slide we have already calculated the forward pass, right? And I have kept all those the forward path calculation here for our reference, right? If you see here, I have just kept 0, 2, 3, 2, 9, 20. I'm basically all the upper half, which is basically your early start duration. So I have kept all those here. Now let's do the backward path calculation. And remember one basic rule for calculating the backward pass calculation is, in forward pass what we did, we started adding the duration in our previous ES calculation, or previous activities ES calculation. In backward pass, from the last node we will start reducing our duration. Whichever path we are following, we will reduce that duration. So that's what we are going to do for backward path calculation. So let's say this is our last node, right? And so the LC for this last node should be your same as ES, right? Because this is the last node and it's the completion of that network. So it means your LC, or let's say your early start, should always be equal to your late completion. Okay, now once we calculated this LC, let's move to the next path. Let's say from n9 to n8. Now for this represent a duration of 8, so if you want to calculate the LC, this will be equal to 28, which is your last LC calculation, minus 8 equal to 20. So, and there is only one path is coming out, so this means 20 is your LC. Okay, now for this path from n9 to n7, if you see the duration is 12, so we will simply take the last LC calculation, 28 minus 12, 16 is your the LC for this node. Okay, now for node 6, if you see there are two arrows are coming out, one is for K, another one is for L. So we need to calculate the two LCs and then take the minimum of that. So for L it will be 28 minus 3, that is your 25. Okay, and for this one it will be your basically 20 minus 4, that is your 16. So we have 16 and 25, and minimum is 16, so this will be your 16. For this node, LC will be your 16. Okay, now let's move to the node 5. For node 5 it will be simple, 20 minus 5, because there is first thing, there's one row coming out of it, and if you just simply it will be your 15. Okay, Now moving on to the node 4. Okay, now if you see node 4, there are two activity which is going out. One is for H, one is for I. So we need to calculate for these both rows or both, line. So remember the LC calculated, last LC for node 6 is 16. So 16 minus duration is 6, so that will be 10. If you see for this path, LC was 16 but duration is 2, so that is becoming 14. So we have 10 and 14. So 10 is the minimum, so we'll keep 10 here. Okay, now let's move to the node 3. Now for the node 3, remember there's two activity which is going out. One is your G3, sorry, activity G, which is duration with 3, activity D with duration of 5. So for this path, let's say N3 to N4 or N4 to N3, 10 was the last calculated LC, minus 5 is the duration. 10 minus 5 equal to 5, right? This is for this path, and this path, if you see, 16 was calculated last LC, 3 is the duration, so 13. Now we have 5 and 3, so 5 is minimum, so we are going to keep 5 as a LC for this, right? Now let's move to the node number 2, right? In the node number 2, if you see here, 15 was the last LC calculation, so 15 minus 7 is 8. Now for this node, if you see here, F, which is representing activity F, 16 was LC, so 16 minus 3 is your 13. So we have 8 and 13, and out of those 8 is a minimum, so this will be your LC here. Okay, now we have come here node N2, N3 is finished, N4 is finished. Now let's go to the last or the first node, which is N1, right? Now at N1 there's three activity which is going on, A, B and C. So for A path, for this path it will be 8 minus 2, which is a 6. For this one it will be your 5 minus 5, which is a 0. This one it will be simply 10 minus 4, which is a 6. Now out of 6, 0 and 6, 0 is minimum, so we'll keep 0 as your LC. Now as a general rule, if you want to quickly find out whether network is right or wrong, if you do the every calculation right, so your first activity should always have both as 0, right? And your last activity should always be having the same, the ES equal to EC. So whatever the days or duration calculated through the ES, that will be same as your LC. So if you quickly see the first and last node, and if they are following this rule, it means your network is correct. And if it's not, then something is wrong with your network. Okay. So now let's find out how to identify the critical path itself, right? We already did the forward pass, backward pass. Let's utilize this information, early start and late completion, and arrive at our answer. So once you find out your forward pass and backward pass duration, then it's become very easy to find out your critical path. And then based on that critical path, we will find out the project completion duration. So let's quickly find out how to identify your critical path and then how to calculate your project completion duration. So if you remember, there were three questions in our, three parts in our question. One was CPM network. We already, drawn our network. Then the question was critical path and project completion time, right? This is what we are trying to find out. And to do that, we basically did the forward pass and backward pass, right? So these are the information from ES and LC I have kept for each node. For each node, if you see, these are the values which we have created, right? Now after identifying this value, how to identify the critical path? Okay, so to identify the critical path, let me quickly give you what exactly I mean by the critical path. What is the logic we call it as a critical path? So here if you see, I have kept that network, right? And these are the logics which we have learned earlier about the critical path, right? This is a critical this is a critical path logic, right? Okay, now let's start with N1. So let's start identify the N1. Remember what we earlier learned, that your ES should be equal to your early start should be equal to late completion. So here if you see 0 0, these are equal, it means this will be the part of your critical network, right? This will be critical path, this node. Then we have this
node n2 here, ES is 2 and then late completion 8, but it means not going to be a part of your critical path. But if you see the node 3, 5 and 5, right, both are equal, it means this is going to be part of your critical network. Then you have the n4, same condition, 10. Then for n6, 16, 16, n8, 20, 20, and then n9. Of course, this is last node activity, so that is here 28, 28. Now, which is a critical path, right? So if you start from here, right, if you start from here, n1 to n3, so this is what is your critical path, that's for sure, right? And here if you see both, if you make calculate this logic, which is basically your late completion minus previous late completion, so 5 minus 0 5, 5 minus 0 5 for both, it means this is definitely a critical path network, right? Then from node 3 you can go here directly to n6 or n5, right? But if you try to see or try to find out this logic for n3 to n6, which is 16 minus 3 or 16 minus 5, right, which is 11, but your duration is 3, so 11 is not equal to 3, it means this is not going to be your critical path, right? So that's why you need to move here, right? So from n1 to n2 to n4, okay? Then from n4 again there's only n6, right? This is not a critical network, so of course you will move here. So this is your critical path, and then from n6 you have just only one 20 20, so that will move here, and then from n8 to n9, okay? So your critical nodes or critical path nodes are basically n1 to n3 to n4 to n6 to n8 to n9, right? Now if you want to calculate the duration of the project completion duration, so it is simply nothing but the summation of the activity duration of those nodes. So for node n1 you have the activity B, for node n3, right, n to n4, this is activity D. Then for n4 this is your B, right? Then for n4, let's say this is your D, and from n4 to n6 that's taken D, and then from n6 to n8 this is your K, and then you have this n8 to n9, that is your n, right? So if you add this duration, it will simply 5 plus D is your 5 plus if you see the H duration, I think we missed this H here, so H will be a 6 plus then you have the K, which is your 4 plus then this duration is your 8, so which basically comes to 28, right? Here I think we have missed H. So just to fairly write it, so your critical path activities is basically nothing but B to D to H to K to N, right? And then we'll go to the last node, right? And then accordingly it's your 28, and the summation of the duration is 5 plus 5, 6 and 4 and 8, and that's what gives us 28 as a duration. So this is how you calculate your critical path. So this is your critical path, and this is how you're going to calculate your duration.
So once you're done with the forward pass and backward pass, and then you find out the critical path and your project completion duration, the next step is to basically find out what is your free float and the total float. Free float and total float are related to non-critical activity, which plays a very important role for completion of your project.
So in previous slides, we have already learned the CPM network, how to draw and then calculate it. Then we have already learned how to find the critical path. Then we have project completion. So previously we identified, right, N1, N2, N3, N4, N6, and N8, and N9 is going to be your critical path. So this is your critical path, right? And the duration is your 28. So this we have already done. Now the third question is compute the total float and free float for non-critical, right? So before going into the calculation of the free float and total float, one thing I would like to emphasize here: except these activities, so these, sorry, B, D and H and K and N, these are all your critical activities, right? And other activities like A, E, J, L, M, I is your non-critical activity, right? And that's why we are saying total float. Remember, for critical activity, float is always 0, right? That's always the float for critical activity. Is always 0, and that's why we call them critical, because you cannot shift those activity without impacting the overall project duration. So let's calculate the critical non-critical activities floats and free floats. Okay, so here we will be forming a table, and from there against that we will be calculating critical and non-critical activities as well as their applicable floats. And if you calculate this, if you apply the formula, you will see from those calculations that float against each critical activity is 0, and for non-critical you will get according to the duration or the formula which we have. So let's understand what the total float is. Right? Total float basically refers to the amount of time that a task can be delayed without affecting the completion date of the project, right? So what does mean by the completion date of the project? So suppose this is the network diagram of a project, and it has to start on day 0, right? And then it has to finish, as per our network diagram, day 8, day 28, sorry, right? So this is the day of the completion, and which is supposed to be finished. Now what happens when projects start and between the end of the project, a lot of changes may occur. Let's say, suppose you want to decide to delay some activity, some resource is not available, some the person who is supposed to work on some activity is not available, so you need to delay. And if you delay this activity, definitely that's going to impact your project. So in that case, if you want to find out that even if you delay some activity by some days, whether that will impact your overall project duration or not, right? Whether that will impact your completion date or not. And if it's so, then what are those activities which can be delayed, and what are those activities which cannot be delayed, right? So this is what it's mean, or this is what basically the purpose of the total float is, to identify those activity which can be delayed and by how much, right? So let's say when a project is delayed, basically it can impact the two things. One is definitely the overall duration of the project, right? Overall duration of a project. And then suppose if any activity is delayed, it will be impacting your next succeeding activity. Let's say if this activity is A is delayed, then it may impact to E and F, because these are connected to these two activity. So idea is, let's find out by how much duration this activity can be delayed, so that it is not impacted, or the project duration is not impacted. So if you want to check the total project impact, that is basically what is mean by the total float, by how much your project activities will be delayed, so that even though you delay by that activity, your project is not going to delay. Or then the next thing is a free float. Free float basically refers to the amount of time that task can be delayed without affecting the start date of subsequent task. Means basically how much time or how much day you can delay a certain activity, but still you can meet your project completion date, right? So this is what is mean by your free float. So total float, if we see the formula, so you basically, total float is nothing but, remember, we have calculated early start and late completion. So late completion of the next activity minus early start of previous activity minus duration. That will be a total float. And if you want to calculate the free float, that will be early start of your let's say the current activity minus early start of your previous activity minus the duration of that activity, right? So this is what we are going to calculate, and we'll put in the tabular format and see for what activity how much float we are getting and what actually does it mean in physical sense, right? In terms of project, what exactly does that information gives us. So that's what we are going to do in our next session. So this is the table which I have kept here. So we have given this information: list of activity, list of processor, and duration. So we have, remember, calculated this network diagram, and then based on the network diagram we have basically calculated this early start and late completions for each nodes, right? Each nodes having this boxes you can see. Now the question is that what is the total float? So let's calculate for each activity what is the total float. So let's say for total float for activity A. So remember the formula is basically this is your J, right, and this is your I. Okay, so the LC late completion of J is 8 and early start of I is 0, right, minus duration is 2. Okay, so this basically becomes 6. So the total float for A is 6. Okay, now let's calculate for E. E is basically again this is your, let's say this is I, this is J. So 15 is your late completion minus early start is what, 2 minus 7 is your, okay, so this will basically gives you 15 minus let's say 8 minus 2 is your 6. So this is going to give you 6, right? So total float for E is 6, right? Then coming to the B, right, let's calculate for the B. So B, again we have the 5 as a late completion, and then early start is 0 for node 1. So basically your formula is nothing but 5 minus 0 minus 5, which is 0. So for B it is 0. Then for the C, 10 minus 4, right, minus 0. So basically 10 minus 0 minus 4, this is duration, this is ASI, and then early start, and this is late completion, so which is equal to 6. So for activity total float is 6. Now for the D, if we move through D here, so we have the late, this is your, remember, this is your I and this is your J. Okay, now so if this is your I, this is your J, so let's say 10, right, minus 5 minus duration is 5, so this is equal to 0. So D is 0. Now for F, where is F? F is here, right? So this is becoming I, this is your J. Now remember this is 16 is your LC, so 16 minus early start is 2 minus duration is 3, so this becomes 11. So 11. Then G, activity G is, remember for activity G, this is your I, this is your J. 16 is a late completion date minus here we have the 5 minus duration is 3, so basically 8. Okay, here we have, this is G. Then let's go to H. For H, again this is your I, this is your J. 16 minus 10 minus 6, so which is your 0. Then for I, again for I you can say we have 12, we have 16 again. 16 minus this one is 2. Okay, So 2 is duration minus, for this node we have 10, so 4. Similarly for j is basically 20, right? 20 minus 9, right? And then minus 5, right? So 14 minus 20 is your 6, and then this is your j. Now let's go to k. Again we have 20, right? Early start is 16, minus duration is 4, so that's become 0. K is 0. And then for L is again 28 minus 16, right? Minus 3, right? So basically this is 9. Okay, then M, let's go to M, where we have, where's M? M is here. Okay, now for M again 28 minus 12 minus, remember 12 is from here, duration is 12, so that is 4. So that is 4. Now where is N? Here is N, right? So 28 minus 20 minus 8, that is equal to 0. So this is a 0. So this is your total flow, right? Now if you see 0, B, right? And then we have the D, right? Then we have the H, then we have K, and then we have N. These all activities are where total float equal to 0, right? So it means if you see this, so this is activity B, this is your D, right? This is your H, then this is your K, and this is your N. So if you see at the all critical, and this was a critical path, right? Remember this one we made actually our critical path, B to D to H to K to N, right? This was a critical path we identified earlier. Okay, and this critical path, all the total float are 0, and it should be 0. So this is another way of checking your problem whether that's correct or not. So critical path, all the activity, total float should be 0. Okay, now coming to the next thing, that is your free float. Now for the free float, if you see, formula is that early start, previous, the current minus previous minus duration, simple. So if you start for early one, right? Let me just choose another color. So here, okay. So let's make early start. Now for early start, for activity A, what will be the early start? So your early start is, let's say for this activity A, so this is 2, right? Minus 0 minus 2 equal to 0. So for free float for the activity A is 0. It means this activity cannot be delayed, right? Because it has free float of 0. Then let's go to activity B. Where is activity B? Activity B is here. And then again for ES is for this one is what? 5 minus 0 minus 5, that is equal to 0. Okay, then for C, early start is simple, 10 minus 0 minus 4, that is equal to 6, that is equal to 6. Now for the D, activity D, where it is, activity D is here. So what is the early start? Early start is 10 minus, for this one, 5 minus 5 equal to 0, so it is 0. Then for activity E, where is activity E? Activity E is here, and then again 9 minus 2 minus 7, what it is, 0. Okay, now for activity F, if you see this one, so we calculate this activity. Remember, this is 16 minus 2 minus 3, that is what, 16 minus 2 minus 3 is 11, so this is 11. Then 8, G, activity G, where is activity G? Activity G is here, and if I see this coming to this node, so 16 minus this node is 5 minus 3, so that is 8. Okay, then H, where is H? H is here, let me just put it here. For H it will be like this. So H is, again, this is 16, right, minus this is a node 10 minus, what is the duration, 6, right? So this is 0, and it should be 0 because it's on critical path, right? It cannot be delayed. Then I, where is I? Sorry, it's cluttered. Where is it? It's here, right? For I, it's again 12 minus 10 minus, that is 2, that is 0. Okay, then for J, Hij, J is here, and then this is a node 20 minus 9 minus 5, right? So 20 minus 16, sorry, 14 is 6. And then for K, where is K? K is this one. Let me pull it here. So for K, if you see, this is the node, right? This is the 2 node, and 6 and 8. 20 is ES minus, for this one it is 16, so 4 minus 4, oops, which is basically 0. Then for L, if you see, where's the, here, so L, again, this is a node 28 minus, this is 16, right, minus 3, which is okay, so what is it, 6, 9, right, 19, so this, I think it's 9. Wait a minute, oops, yeah, that's fine. Then M, where's this, where it is, where's this M? Here, right, this is M. So let's calculate for M. M is 28 minus this, so 28 minus 12, right, which 16 minus 12, that is 4, so 4. Then for N, okay, N is in critical path, so ideally that should be 0, but we can calculate. So N is this one, let me bring it here. N is this one, okay, so 28 and this 20, so 28 minus 20 minus 8, 8 is the duration, so this is equal to 0, and so 0, right? So from here, if you see, all additional, all the critical path, whether total float or free float, all will be 0, that's for sure. Then there are some additional activity which cannot be delayed further, right? So A, you cannot delete, you cannot delay this, even though this A is not in critical path, but still you cannot delay this, otherwise it will impact your successor activity. Then C, you can delay it by 6 days, right, and still you can meet the completion date. F, you can delay by 11 days, right, and no issue with that, and you will still complete the project in 28 days. G you can delay by 11 days and still complete the project. 6 sorry, J you can delay by 6 day. Similarly L and M. So this is what the significance is. Now you can clearly see if something bad happens to your project, which activity you can delay and by how much. And that's what the purpose of is total float and free float, right? So I think this all covers the critical aspects of the critical path management. Now let's understand what are the other aspects of the critical path in terms of project management and how it's beneficial for the project.
So once we learn all those concepts of the CPM network, let's utilize this concept and solve various problems so that it will be helpful for you to understand this better.
Okay, so we have solved the critical path network problem with various nodes method. Now there's another kind of problem which you might be getting in, especially for students. You may get those questions in your exam, and that is basically activity is given in terms of relationship. So here if you see, there's no information is given specifically or separately about the predecessors, right? So here there is no another column for predecessor. In the activity itself is defined some sort of logic is there, right? So you need to basically understand from this the activity definition itself and draw the network diagram, right? And the requirement of the question is same. First you need to draw the diagram, then you need to find the early start, right, and late finish, and then you need to determine the critical path, total project duration, and then total and free floats, right? So in this type of question again, you need to follow the same method, right? And before drawing into the network itself, you need to first understand the information. So if you see here the activity which is given here it says activity 1 and 2 are related like this, activity 1 and 3 are related like this, right? And the duration is 4 for 1 2, and then 1 to 3 is 1. It means in your critical path network diagram there will be a node where the 1 is a common node and 2 and 3 are coming out of that node, right? Then if you see for 2 to 4 and 3 to 4, again 4 seems common node where 2 and 3 activity are converging to 4. So 4 will be a node where 2 and 4 activity will be converging on finishing at this point, right? And the duration of those are 1 and 1. Then similarly for 3 and if you see further 3 4 and 3 5, in this case 3 is become a node from where 4 and 5 will be coming out, right? And then the duration of 3 to 5 is 6, and then for 4 to 9 again this is a different activity, but then here if you see the duration is 5. Then again another activity 5 to 6 and 5 to 7. It means 5 is a node from where 6 activity this activity is going out starting, let's say, and 5 to 7 starting from this 5. So from 5 we'll be seeing basically the 2 arc which is going out, right? And one of the duration will be 4, another one is 8. If you go for 6 to 8 and 7 to 8, here again see the 8 is common. It means 8 is a converging point for activity 6 and 7, right? And then for 8 to 9 and 9 to 10, if you see again 8 is getting converged to the 10 and 9 activity getting converged to 10. So if you see here 10 is a last converging point. So from here it is clear that activity 1, this will be your starting point and 10 will be your last finishing node, right? And the durations are given like this. So let's draw this in a network format and let's see how does it looks, right? So starting with 1, so we have seen that there will be node 1, right? So let's make it 1, right? And then from 1 if you see 2 is there's a 2 row is going out, or 2 arrow is going out, as 1 2 and 1 3. And if you see here further, is there anything else which is going out from 1? So no, these are the only 2 activity which will be coming out. So let's make 2, right? And then another one is your 3, okay, right? And then let's say what are the other so these activity we have drawn, we have drawn, right? Now let's come to this one. So 2 to 4, 3 to 4. Now 2 is this one. So 2 to 4 and 3 to 4. It means 4 is converging point for 2 and 3, right? Remember, it says 2 to 4 and 3 to 4 immediately. So we have done this, right? Now let's see the 3 to 5. Okay, and then 5 is further will be node for 6 and 7. So let's draw 3 to 5. Okay, and then after that we have 4 to 9. So there's another row which is for, let's say, 9, right? 4 to 9. We'll put the duration later in last. Let's first draw, and then 5 to 6. Okay, 5 and then 5 to 6. So remember here 5 to 6 and 5 to 7, two activities are coming out. So 5 to 6, 5 to 7. So let me just put 6 here, let me just put 7 here. Okay, so we have done this and this and this. Now let's go to 6 to 8. Now where is 6? Our 6 is ending here, and then we need to have and if you see here, there's these 6 and 7 both are converging at 8. So we need to have somewhere 8 here, right, where 6 and 7 are getting converged, right? This basically satisfy this condition, 6 to 7 and 7 to 8. So 6 to 7, 7 to 8. Okay, this is also drawn. Now then we have 8 to 10 and 9 to 10. So there, and 10 is the finishing activity. So let's say this is 10 and we have 9 to 10 and then 8 to 10. So this completes our network diagram, right? And if we can mention the duration also here. So let's say for 1 to 4 the duration is, 1 to 2 duration is 4, 1 to 3 duration is 1, 2 to 4 duration is 1, then 3 to 4 duration is 1, 3 to 5 duration is 6, 5 to 6 duration is 4, 4 to 9 duration is 5, and then 5 to 7 duration is 8, 6 to 8 duration is 1, 7 to 8 duration is 2, 8 to 10 duration is 5, then 9 to 10 duration is 7, right? So this become your CPM network diagram, right? And this basically completes this. Okay, now let's calculate the early start and late finish. Remember, this is early start, not easy. Okay, so let's calculate this two things, right? So I have kept this early starts and early, the early start, which is basically related to our forward pass, right? And this is what we have learned earlier, so I'm not going to detail in this of this forward pass method. If you want to know, then you can go back to the previous session and learn about this early start and late completion, which is basically representing a backward pass. And just for the reference, I have kept the formula here so that you guys can immediately refer when I'm working on this the network diagram. So we have already drawn this network diagram in our previous slide. Right, now let's calculate those early and the late completion durations. So starting with node 1, right, again for starting with node 1, early start is always 0, so we'll keep it 0, and then we'll move to the node 2. Node 2 is basically having duration of 4, and then early start, there is nothing but your simply if you see the formula, max of ASI and duration, and here there is only one row is entering in this node, so this will be basically nothing but 0 plus 4 equal to 4. So this is a 4, right? Now moving on to node 4. Now node 4 is basically having two paths, right? One is coming from 2, another is coming from 3. So let's first calculate this 3, right? So for 3, again 0 is early start, so 0 plus 1, this will be 1, right? Now from early start, if you see here for node 4, The early start is 1, here is 4. If I follow this path, so it will be 1, and then duration is 1, so 1 plus 1 equal to 2. That should be early path, or early, early start duration. If I follow this path, then it should be 4 plus 1 equal to 5, right? So we have two options, one is 2, another is 5. 5 is max, so I'm going to choose 5 because this is our forward pass, right? So we are going to choose the maximum early start duration. Now coming to the node 9, so here remember we have already calculated the 5, and now if we try to calculate the early start for the duration, so 5 plus 5 is the duration, which is 10, and so single, there's no other row which is coming in, so we just keep it as 10, right? Now if you see here for 5, right, for 5 there is again single row which is coming in, single arrow, and then if you try to calculate here, so remember we have calculated early start earlier here for 1 and 6. 6 plus 1 7, so 7 is going to your the early start for this node. Now moving on to the 6. Now here we have 7, so if we go to the 6 here, so 7 is early start for the previous, which is this one. Then if you move here for this one, so this should be 7 plus 4, right? And then for this one, basically there is no other node, so that's basically your 11 is the early start duration. Okay, then if you move to this node, node 8, here we are having two row which is entering. One is from 6 to 8, one is from 7 to 8, right? So before that we need to calculate the 7 node, right? For 7 node, if you see which is coming out from here, so 7 was the early start which calculated for this node. 7 plus 8, right, so which is basically a 15 is the early start. Now we have the early start for both 6 and 7, so if you see 15 plus 2, right, 15 plus 2, so it should be 17, right? As per this path says that no, I have just 11 early start and then 1 is duration, so 1 plus 1, this is 12. Now we have 12 and 17, so 17 is max, so obviously we will take 17 as early start duration because we are doing the forward pass. Okay, so we have this 17 here. And then now for 10, node 10, again we are seeing two rows are coming in. One is from 9 to 10, another one is 8 to 10. Okay, so again we apply the same process. So 17 is early start for this path, 17 plus 5, right, which basically gives you 22. Okay, and if I follow this path, the 10 was early start which was previously calculated, so 10 plus 7, right, which is basically 17. So I have a 17 and 22. Obviously 22 is greater, so I will take 22, right? So this is your forward pass. Now let's move and let's calculate the backward pass, right? Or let me put this another slide with a clearer so that we can have more better understanding. So okay, so we have already calculated the forward pass, right, and we see all the values of ES which is there, right? These are all ES values. Now let's calculate for late completion, right? Now late completion, this is 10 is your ending node, right? Remember, this is your ending node. So for ending node, your ES is basically equal to your late completion, so which is basically means late completion for backward pass or for the ending node is your 22. So now let's start our backward pass calculation. Okay, so if we go down, right, where the two path which is coming in, so one is this one, another is 9. So if you go down here, so 22 was your initial this thing, and then from 22 the duration is 5, so we'll do backward. So 22 minus 5, which is your 17, so which basically means the late completion, this one for node is 17, right? Now if you take for this path for 9, so 22, right, 22 minus 7 again, so 22 minus 7 basically means it's your 15, right? So means this is a late completion as 15. Now remember there were no other nodes, so we don't have to check the 2 times number of other rows, so it is 15 and then there is just 17. Now when we come to this node 6 and 7, so here remember we have already calculated the 17. Now if you come to node 7, so 17 minus 2 is your 15, right, which is here. If you see 17 minus 1, that is your, let me just write it, 17 minus 1, that is your 16. 1 is duration, 17 is last LC calculation. So here we reach this, if we covered this node. Now coming to the 5, we have, you know, the 2 arrows connected. One is 6 to 5, another is 7 to 5. So we need to calculate the 2 LCs. So remember this is 15, so 15 minus 8, right, well it's a 7. Here if we say 16 minus 4, right, this is 16, so 16 minus 4 is the duration, so this should be your, what it is, 12, right. Now we have 12 and we have 7. Now for backward pass we always take the minimum, right, so minimum is 7, we'll consider 7, right. Now coming back to the node 3, okay. Now node 3 is basically having the 2 rows, so I think before coming to node 3 let's solve 4, because we will be needing 4 LC, right. So here we have last time calculated load 9 as 15, 15 minus 5, right, 15 minus 5, that is your 10, okay. Now the 10 is your LC for this node. Now we got the LC for 10. Now let's, for this part from 4 to 3, that is your 10 minus 1 is the duration here, so remember it's a 9, so either it should be 9, or let's say for this part, right, 7 is the LC, so 7 minus 6, which is 1, so we have 9 or 1 for this. Now we know for backward it's always minimum, so we take 1, right. And then if you see for node 1, then again there's 2 rows are coming. One is coming from 2 to 1, 3 to 1. So to solve 2 to 1, we need to have the LC for this node 2. So again we will apply the same formula. 10 is the last LC calculation, so LC equal to 10. Duration is this, so minus 1, so which is your 9. So 9 is your LC for here. Now let's calculate the LC for late completion date for node 1, right. This is what we came back to starting node, right. So 9 minus 4 equal to 5, right, or here we have 1 minus 1 equal to 0, so we have 0 or 5. Well, if we have to take minimum, it has to be 0, and biologically it should be 0, right. So if your network is correct, always your late and ES of the starting node will be always, you will be getting a 0, right. You start with 0, when you come back for the whole network, then if your calculations are right, your LC should be 0. If it's not 0, that means something's wrong, okay. So this is how you have to, you know, calculate. So now we have the early start dates, early start, let's say early start duration, or late completion or late finish duration. So this is what we already solved for this network, right. Let's solve the critical part, okay. Okay, so we have already completed our network diagram, okay. So we have already, you know, completed our network diagram, and this is your CPM you know, network diagram, right. Now the next question is that identify the critical path, and if you see here I have written formula how to identify the critical path. So it is basically your preceding activity, your early start and late completion for preceding, as well as, you know, the next activity, those has to be 0. And also if you subtract early start and early, you know, for preceding activity, and the late completion date for preceding and succeeding activity, it should give you the duration, right. So what I mean by that, if this is your ES, early start and late late completion and late finishing date. So if you see 0 minus 0, it's a 0, right? And if you see here 1 minus 1, so basically this activity is going to be your, this node is going to be in your the critical path. So that is first 3 7 7, this is 5, this is not going to be on critical path. Again, this is 15 15, and then we have 18 17 17, and then we have 20 22. So basically this is ending node. So this is what will be your critical path, right? So if someone says we want to identify the critical path, so that should be 1 2 2, oh sorry, 1 to 3 to 5 to 7 to 8 to 10, right? And if you see, if you want to find the duration, so 1, right, 1 plus 6 plus 8 plus 2 plus 5. So just check 1 2 6 8 2 and 5, right? And if you add it, right, so that should give you 22, which is just equal to your finishing time, early start finish duration and late completion duration for your last node, right? So this is your critical path for this problem. So this is how you need to identify your critical path for your CPM network. So I have already mentioned the early start time and late completion here. So if you see, you need to just consider the I and J node, and for all I's you need to start all those start dates, yes, start date, and for all the J node you need to mention this late completion time, right? Now coming to the next point, which is total float and free float. So for total float, the formula is very simple: LCJ minus ESI minus duration, right? So we'll start first calculating the total float for each one, right? So if you see here, the total float for this activity 1 to 2 is basically what your LCJ, this is basically J even this, and LC is this one. So 9 minus 0 minus 4, 4 is your duration and 0 is your ESI, right? So which is equal to 5. Then if you go for total float here, this is what basically this becomes J, right? So LC is 10 minus 4 minus 1 is the duration, which basically gives you 4, oh sorry, 5, right? This is 10. Then for here, if you give 15, right, minus 5 minus 5, which is basically your 5, okay? Then for this one we give 22 minus 10, right, which is 12, minus 7, which gives you 5, right? Then this is fine, and then we'll come to the, where is that node? Yeah, so for 3 to 4, again same, LC is 10, right, is 1 minus 1, which is your 8. Here if we calculate total float, which is 7 minus 1 minus 6, which is your 0, right? Similarly for this one, if we calculate 15 minus 7 minus 8, that's equal to 0. For this one also, if we calculate 17 minus 15 minus 2, that is also 0. And then for this one again 22, right, minus 5 minus 17, which equals to 0. So for these, and for this activity, let's say 16 minus 4 minus what is this, 7, right? So that will be again 7 5, okay? Now let's come to this one. Okay, so we have 17 here, right? Remember, this is your LC. 17, this is your ES. 17 minus 11 minus 1, right? Which basically gives you, you know, 5. Okay, so we calculated total float for all the activity. Let's say from 1 to 2, this is total float. 5, 1 to 3, this is the float. 8, 2 to 4. Where is 2 to 4? 2 to 4 is this one. Sorry, 5. And then 3 to 4. I think we already did it, right? 3 to 4 is, oh, 3 to 4 is 8, but 1 to 3 we haven't calculated, right? So we need to calculate this. So 1 minus, this is 0 minus 1, which is 0. So they should be 0. Okay, 1 to 3, this was 8. And then 3 to 5, 3 to 5 is 0. 4 to 9, 4 to 9, 4 to 9, where's the 4 to 9? 4 to 9 is this one, 5. Okay, then 5 to 6, 5 to 6, this one, 4. 5 to 7, 0. And then 7 to 8, 7 to 8 again it should be 0, because in critical path 6 to 8, 6 to 8 is 5, 5. 8 to 10, 8 to 10, 8 to 10 is again 0. And then 9 to 10, 9 to 10 is this one, right? 9 to 10, this one is, it's giving me 5, right? So these are the total float. Remember this, 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 this is just, I'm highlighting it for you, easy reference. Okay, so if you see here for activity 1 to 3, 0 total float. 3 to 5, 0. Then for 5 to 7, 0. 7 to 8, 0. 8 to 10, 0, 9. So if you see here, this is 0. Remember, this was our critical path, right? And that's why these activities are getting 0 float. So if you see here, this is what represent our critical path, and all the total floats mentioned here are 0. Okay, now let's calculate the free float, right? Let me change the color. Let me take this one. So for the free float, it is ESA minus ESI minus TJ. So if this one, which is basically this, is your J and this is your I, so it should be, what is this, 4 minus 0 minus 4, which is your 0. For this part 2 to 4, let's mention here only 0. Then for 1 2 3, let's calculate for this one, again 1 and then 0. 1 minus 0, sorry, 1 minus 0 minus 1 equal to 0, right? So this will be your 0. Then moving to 2 to 4, 2 to 4, again this is 5 and 4, so which is basically nothing but 5 minus 4 minus duration is 1, so which is again 0. Then we move to 3 to 4, 3 to 4, 3 to 4, this one. So again this is ASA, 5 minus 1 minus 1, so which is coming as your 3. Then 4 to 9, 4 to 9, where is 4 to 9? 4 to 9 is here. Then 10 minus 5 minus 5, which is again 0. Then we have 4 to 9, 4, oh, we have already taken 3 to 5, right? That was 4 to 9 is this one, so 3 to 5, 3 to 5 is this one. Oh, sorry, so 3 to 5, to calculate this we need to again 7 minus 1 minus 6, that is 0, and that's 3 to 5, right? 3 to 5 is 0. 4 to 9 is also 0. 3 to 4 is 3 to 4 is 3, right? Let's check that. 5 minus 1, yeah. So let's round it so that we know what we calculated. Then let's go to 5 to 6. 5 to 6, right? Now 5 to 6 is what? This one and then this one. So 11 minus 7 minus 4, right? And it should give you 7 plus 4, 11, right? Means it's a 0 for this part. 5 to 6. Then 5 to 7. 5 to 7 we have this one, right? So here if you see 15, then this is your 7 minus 8 and it's 0, and this is a critical part, so it should be 0. Now 6 to 8. 6 to 8 is this one, right? 17 and 11. So if we calculate this, 17 minus 11 minus 1 should be 5, right? And then it's 5, okay. Then 7 to 8. 7 to 8, where is 7 to 8? Is this one, right? So just take 17 minus 15 minus 2 is 0, which is 0. 8 to 10. 8 to 10 is this one, right? So we have 22. This is 17 minus 17 minus 5, which is again 0. So this is 0. And then 9 to 10 is this one. 9 to 10 this one. So 22 minus 10 minus 7, which is 5. So we'll take 5. Okay. So let's take another example where we will be again drawing the CPM network and understand how to calculate the critical path. So we will be following the same logic. So let's first draw our CPM network. So here if you see in this activity, we are given activity from A to F, and then we have given the immediate predecessor for those activity, and we have the durations given in this column 3. Now we need to calculate the total float, free float. Before that we need to calculate the CPM network, then critical path, and of course the project completion time. So starting with the node 1, right? So let's say this is our node 1, okay, right? And then from node 1, if you see, the activity A doesn't require any predecessor, so activity A can immediately start, right? So let's say this is your node 2 and this is your activity A. Now after that, if you see, the activity B and C are starting after activity A. It means A has to be the activity A should be ending at a node where B and C are starting, right? Or B or C are branching out. So it should be like this, because from node here activity A is finishing, and from this node your activity B and C is starting, right? So let's say this is node 3 and this is node 4. Okay, now if you see here from the next activity, so we have basically finished activity A, right? Activity B, activity C. Now for activity D, if you see, activity D is starting after B, right? So we can just take activity D and just call it node 5. But now if you see, D is basically finishing at a point where E is also converging, right? Keep this in mind. So it means that there has to be an activity where, or there has to be a node where D and E are converging, okay? And from that node onwards, your F will be branching out, right? It means, and if you see for the activity, we have already drawn the D. For activity E, it's starting after C. So it means that this is the node where your sorry, this is activity E, right? So here at node 5 your activity D and E is basically converging, and after this node 5 we have one activity left, which is your node F, and which is basically, you know, representing your activity F. So this is how your CPM network should be, and we can add here our duration. So let me add our durations here. This is 5, 4, and this is again 5, 6, and then E is your, how much, this is 3, F is your 4, right? So this is your CPM network is drawn for this for this project. And then we will be calculating later on the text flow, the total flow to free float, and then the critical path as well. So we have previously discussed our network diagram in our previous slide. Now let's start calculating our early start and late completion. So if you see here the node 1, which is a starting node, so it will start with 0. So early start for this node 1 is your 0, and now we move for node 2, that is basically 0 plus 5. 5 is your duration, so your early start for this node will be your 5, right? Now from this node we are seeing the two activity branching out. So for B4, activity B4, if you go to the node 3, will be 5 plus 4, and there's only one node which is coming in, so basically your 9 is your maximum early start, so we'll take 9. Then for this node, if you see there are two activity coming in, so we need to basically solve this one first. So if you see the early start for this node was N2 was 5, so it should be 5 plus 5. So this is a duration, so which is equal to 10, so it means 10 is your early start for this node. Now if you move up here, the two activities are coming in from here. If we calculate the early start for node 3 is n plus 6, which is your 15, and then 10 plus 3, this is your 13. So 15, 13, 15 is maximum, so we'll keep 15 here. And then if you move to for this node, if you see that this node, then let me just draw one more box here. So 15 plus 4 is 19, so 19 is your max here because this one activity is coming in here, right? So this is your early start. Now if you go backward, right, and try to calculate this, that's what we're going to do in our next session. So previously we have calculated the forward pass, right? Now what we are going to do, we are going to do a backward calculation for our network diagram. So if you see here, I have just kept the forward pass value, and now let's calculate the backward pass, right? So for the backward pass, we will go to the last node. Let me just draw one node here so that we can see. Oops. Okay. So if you see here, there should be your 19, right? Minus value. This is your earliest start. Now for the forward backward pass, your last node is there, so it will be simply your same as 19. Now we move to the node 5, so 19 minus 4, right, should be 15. So there's one node which isn't going here, so we'll take 15. Now if you go backward pass here, the two activities are branching out from this node, right? So if you just put here, I think this is missed, so 5, it should be 10, right, the early start. Now if you go here from 19, here we have 15, right? This duration is what, 15 minus 3, 15 is the late completion, remember? So 15 minus 3, that should be 12. If you see here, 15 minus 6, right, which is your nothing but 9, right? For this path again, here we have 12 calculated, so 12 minus 5, right, which is your 7. And then if you see here, 9 minus 4 is the duration, so it's equal to 5. So 5 and 7, 5 is the minimum, so we'll take 5, right? Now here we have just one node, 5 minus 5, which is basically 0, so your late completion is 0, right? So this is how you will calculate your late completion. And then let's identify our critical path. So here I kept everything what we previously calculated, our early starts and the late calculations, right? So if you see here, this is where your early start and late completion is equal. At this node your late completion and early start is equal basically, and then in this node again your early start and late completion equal. But if you try to go here, right, there is no the 10 minus 2, they are not equal, so there will be some delta. And if you see for this node 15 and 15 both are equal, 19 and that's the last node, so obviously it should be equal. So it means if we try to find our critical path, so it should be node 1, node 2 and node 3, node 5 and node 6, right? So it will be your n1 to n2 to n3 to n5 to and 6, right? So if we take the activity, what are basically A to B to D to F, right? These are the, and then this will be your duration. So if you calculate the duration, what A is your 5 plus 4 plus 6 plus 4, which is equal to 19. So 19 year project completion duration. Okay, so this is your critical path, project duration, and the network diagram. Let's move on to calculate the total float and the free float, right, which we have in this column. We will be calculating this one. So previously we have calculated the CPM network. Now let's calculate the total float and free float for this network diagram. So if you see here, I have already mentioned the formulas, which is basically applicable for your total float. So for total float, if you see, it's Lj minus ESI minus duration, and then for free float it is simply your an early start of preceding activity, then the previous activity of early start, and then duration. So if we calculate the total float, let's say for the activity A, so total float will be your LCJ. Let's say for this one, it's basically your 5 minus 0, right? This is your LCA and this is your ESI, and then minus your duration, right? So it's basically means total float is 0. So for activity A, total float is 0, right? Now if we go for activity B, it is again this is LCA 9 minus 5 minus 4, that is equal to 0, and then it's basically 0, right? And if you go for this one again, it should be 0. Why? Because remember, this is your critical path, right? And float on a critical path is always 0. But anyway, let's calculate. So 15 minus 9 minus 6, which is going to give you 0, right? And that's for D, so it's a 0. Similarly for F, if you see here, again it's going to give you the same, 19 minus 15 minus 4, that's 0, so it will be 0. Now if you come to calculate for C, it is basically what LC is 12 minus ESI is 5, right, minus duration is 5, so it's going to give you 12 minus 5 minus 1, this is 2, right? So total float for C is 2. Then for E, if you see, calculate the same way. So this is your L, its late completion is 15, early start is a 10 minus 3, if you, it will give you basically 2, right? So this is your 2. So this is what your free float is. Now let's calculate the sorry, that was total float. Now let's calculate the free float. So free float, let me choose another color, right? So for free float, again it's pretty simple. Early start of J minus early start of I minus duration. So let's say for here, if you have the early start is, let's say 5, this is 0, minus duration, so that's become 0. So obviously this will become 0. For B again, it's 9 minus 5 minus 4, that's equal to 0, so it will be 0. And for D also it's going to be 0, but you can calculate that, because remember this is in your critical path. We can calculate that. So for D, let's say 15 minus 9 minus 6, that's 0. Again for here, 19 minus 15 minus 4 equal to 0. So for all critical path, whatever the activity, remember we had the critical path of A to B to D to F, right? So A, B, D and F, they are all having a float as 0. Now for free float for this one, let's calculate for this. So free float for C would be 10 minus 5 minus 5, right? Which is your 0, right? And then for free float for this one will be basically your, let's calculate this, how much, 15 minus 10 minus 3, that's 2, so it will be a 2. Okay, so like this you can calculate your free float also. So this is what your free float column is, and this is total, and this basically completes your this question of CPM network.
So far, we have solved this problem with assumption of that your activity duration will be constant. Remember, we have seen all the durations in our column were constant. It means that we already assume that for completion of any activity, there will be a fixed duration. But in real world, it's never the case. You will never know what will be the exact duration for completion of a particular activity. So there is a factor of probability. There is a factor of uncertainty. And to handle this uncertainty, the Pert technique is utilized to give you the most accurate estimate. And this is what it is utilized in CPM network, and we are going to learn about this in detail in our next session. So let's understand how CPM and Pert are combined together, and then how they are utilized to have a more accurate and more professional estimation of the project duration.
So far we have solved all the problem where the durations are fixed, right? If you see our problem number 1, where we had utilized these durations, right? And these all durations are fixed, right? When I say fixed, means to do this activity A, you are saying that you will take 2 days, right? To do this activity B, you are going to take 5 days. So like this, you have basically confirming in the question or assuming that whatever activity you are doing is going to take the fixed duration, right? This is what your assumption while you drawing your these network diagrams, right? All these network diagrams are based on these fixed durations. So even if you see this question, as well as that this the third one which we solved. Now in the real world or the real projects, when you work, it will be very difficult for you to assign the exact durations. This exact duration is not known many times, right? So you need to have some sort of probability or some estimation what will be your most probable duration which you're going to take, or the time you're going to take to complete that activity, right? So once the probability comes into factor, basically it's required the estimation of the duration of each activity, which you think based on some approximation, some estimation, some probability distribution, you try to identify what will be your most estimated duration, right? And that's what you will need Pert as a technique to estimate those the duration which you will be utilizing for drawing this CPM network. So let's understand what Pert is and how to estimate those duration, and then we will utilize those estimates duration to calculate our network diagram. So if you see here, I have kept this the activity list of activity, right? And for the duration, you can see I have made 3 columns, right? So this is one is your optimistic, this is most likely, and pessimistic. So optimistic means to do an activity, to complete an activity you assume everything go as per your plan. I mean, whatever you plan, whatever the assumptions are, they are going to right. So every single aspects of activity, what you have assumed is going to happen in the same way as you think, right? And that's what means your optimistic case, where you think that everything is going to align as per your expectation. So that's what we call optimistic. Basically, you need to see an activity and understand, what best you can get, or what's the best duration you can complete that activity. That is basically your estimated, or you can say the optimistic, right? When we mention is O is nothing but your optimistic. Then we have the another time column, which is your most. So M is basically donates to your most likely, right? So this is the time which you think that, because in real world not everything is going to happen as per your assumption, right? In projects are dynamic, and they deals with a dynamic situation, and there are a lot of factors which impact your project activity and durations, or the thing you plan to do on a project, they may get impacted, right? So based on the real scenario, the real situation, you may have another estimate, or your another guess, you can say, to complete an activity, which is you think which will be the most likely activity which is going to that activity is going to take, a most likely time which what you are going to spend on the activity to complete it. So that's what it's mean by the most likely, right? So we call it most likely. Okay, and then we have another column that is for P, right? So P is means pessimistic, right? So pessimistic means basically you assume everything will go wrong, right? What is the worst case scenario where you're going to complete an activity, and what is the worst case scenario where you will take that time, right? So obviously in the worst case time, you will require more time to complete an activity, because you anticipate there are several delays, several impacts which is going to incur while you're completing your project activity. So that's what exactly means by your TP, that is a pessimistic time estimate, right? So by having these three estimate, or the three you can say boundary limits, upper, lower, or most likely, you do an estimation by utilizing Pert beta distribution, right? So beta distribution basically probability distribution. I'm not going into detail, but if you can see in the graph, it somewhat look like this, right? Where you can see the most pessimistic value is just considered here, and then optimistic one is here, pessimistic is one here, most likely is here. So what happens that a beta distribution assigns weightage to these three values: the optimistic, pessimistic, and most likely. So what it does, it basically assigns 1/6 weightage to this to optimistic, and 1/6 to pessimistic, and 2/3 to your most likely. So what it happens that one for optimistic, it provide a weightage of 1/6, right? And most likely it's going to provide you 2/3, and then pessimistic, you are going to get 1/6 as a weightage. So this is what you see. If you see the formula of Pert is nothing but optimistic value plus 4 times of most likely plus pessimistic divided by 6, right? This is what is the formula is, and this is what nothing but weightage distribution by using this the weightage to the optimistic. So it is taking basically 1/6, 2/3, and 1/6, right? So this is what your beta distribution is. We are not going to go into detail how we derive this formula. You can go and check on the internet, there's a very detailed information available. But just remember one thing: beta distribution is used when you don't know what exactly your distribution is, but you know what will be the maximum, what will be the minimum, and what is most likely. So the three information about a particular activity or particular event, which based on that you can find out or utilize this beta distribution method to calculate or to estimate what is your most probable or the high probabilistic duration would be for that activity. So that is the purpose of the beta distribution. That's why we always see sometimes it's mentioned as beta Pert distribution, and that's what it's mean by beta, because it's assigned the weightage 1/6, 2/3, and 1/6 for optimistic and most likely and pessimistic. Now if you see the various formula which is we will be using. But if you see for the beta distribution, there is formula for mean, median, mode, standard deviation, skewness, and kurtosis. So I'm not going to detail. This is just all related to your the probabilistic and statistic formula. No need to go into much detail as far as Pert CPM method is concerned. Only thing is that remember there is another column, so this we will be calculating by using this formula, right? This is using by Pert formula. This is for Pert. And then this one, you say variance is nothing but basically this one, right? So it is basically your optimistic minus pessimistic divided by 6, and your variance is basically this one. You need to just calculate. So this is basically standard deviation and just square root. Variance square is basically you take the square root and you get the variance, right? So this is what we are going to calculate in our next slide by utilizing this your Pert distribution, and then we will utilize that duration to calculate our CPM network critical path, and then also what will be the variance in your critical path, right? That's what the utilization of Pert is. And let's try to solve a problem accordingly. So I have calculated this duration using the Pert formula. So these are the basically durations which you can see, estimated duration utilizing the Pert formula, and let's put in our this column. So this is for 1 2 activity is 2, 1 2 3 is 4, then it's for 3 1 6 5 and 7, right? Similarly, by utilizing this variance, so I have calculated this formulas, and then these are our variances, right? So we can just bring in this in our variance column. So that is 1 1 1 0 4 1 4. Okay, so now we have already our variance as well as the durations are ready. Now we can create our network diagram and assign the durations. So if you see all the activity which is given as detail, if you see for all those 3 activity, they are all starting from 1, right? And then if you see for 5, there are 2 node. At 5 node 2 and 3 are ending, and then at 6 4 and 5 are ending. And if you see here, 4 is related to 1 and 5 is basically basically ending where 2 and 3 are starting where 2 and 3 are ending. So by keeping this in mind, let's start drawing our network. So if you see 1 here, then we have basically 2, right? And then we have here 3, right? And then we have 4. Okay, right? I can just put the arrow here, and then from there if you see 5 is a node, but then 5 is basically converging point for 2 and 3. So if you see, draw this, so it should be like this and this, and here you can assign 5, right? And then from 5 you're seeing it's 5 is connecting to 6, as well as from 4 it is connecting to the 6. So most probably this is what your the critical paths should look like, right? And if you assign the duration, so this is basically the duration here. This is 2. Let me change the color. This is 2, and then this is 1 2. Let me erase this first. Right, so for 1 to 2 duration is 2, 1 to 3 duration is 4, 1 to 4 duration is 3, and then 4 to 6, where is the duration? It's a 5, 5 to 6 is 7, 3 to 5 is 6, and 2 to 5 is 1. Okay, so now we got our network diagram. Let's calculate the critical path, the duration of the project, and let's see how we utilize the variance, and then we'll see how we utilize the variances to calculate the probability of completion. So, and that's why we utilize Pert, right? Remember, by utilizing Pert we calculated our variance in the column variance column. This we will be utilizing to calculate the probability of completion of your project, right? So let's start with the critical path determination, and then we'll calculate the other things by utilizing this Pert technique. Okay, so now let's start calculating our critical path, right? So we have already our durations, and then this is our node. So starting node, again start with 0. We start for, and remember this is our early start and this is our late completion. So early start will move to here, so 0 plus 2, this should be a 2, right? Again there is a 1 activity, so no need to worry anything. So 2 plus 1, it's a 3, it should be a 3. And here they are seeing that there is 2 activity which is coming in, right? So we need to first solve this. So if we go here, again there's 1 activity, 0 plus 4, and it should be your 4. 0 plus 3, this should be your 3, right? And then if you move here, so 4 plus 6 is 10, right? And 2 plus 1 is 3, so it means it should be 10, right? Because there are 2 activities are coming in, and 10 is maximum, and we are doing forward pass, right? Then if you see here, this is 3, so 5 plus 3, 8. But if we see here, 10 plus 7, this is 17, right? It means for node 6, 17 is your early start. Then again we will do backward calculation. So 17 is for node 6. Then we go back here, and then if we come back here, so 17 minus 5, right? 17 minus 5 is basically 12, right? If you go here we will see 17 minus 7, that is your 10, right? Now we move to here, 10 minus 3, right? So 10 minus 3 will be your 7. And if we move here, right, in this path, so 10 minus 6, right? 10 minus 6 will be your 4. Okay, and then if you solve here, 3 is 12. Sorry, this way only 12. So if you go here, backward pass, 12 minus 3, this will give you basically 9. Here if you see, if you go to backward calculation, so this will be your 4 minus 4, right, which is 0. And then if you go backward calculation here, for 7 minus 2 is your 5. So we have 5, 0 and 9, and we are doing backward pass, so we will take 0, right? So now if you see here, right, let me just choose another color. Okay, so if you see here, for these activity where ES equal to in late completion, early start, for these node, so basically 1 to 3, right, and 3 to 5 and 5 to 6 is your critical path, right? This is what your critical path is. So if you say what is your critical path, this is basically nothing but 1 to 3, 3 to 5 and 5 to 6, right? And if we add the duration of those, so 4 plus 6 plus 7, which is equal to 17, right? So 17 days is your duration. Now we have already calculated this variance. So next question would be, what is the variance for this the critical path? So remember, for variance you need to add only the variance which is calculated for critical paths, right? So if we calculate the total variance for this project, it will be the variance for 1 to 3, it is 1, right? For variance for 3 to 5, it is 4, and then 5 to 6 is your 4, right? So its variance is nothing but 9. So this is your variance. So now we got the variance, and remember variance is formula of variance, right? If you see, it's a standard deviation square, right? So basically if your variance, or let's say standard deviation, equal to 9, it means sigma is 3, right? Or let's say standard deviation, we call it sigma as standard deviation. Okay, and that was the whole purpose, to utilize PERT formula to find these variances utilizing the beta distribution. So now we have standard deviation, which is 3, and we have our the most likely the project duration, the project completion duration is your 17, right? Now we say we have the duration 17 with standard deviation of 3. What it means that your project duration will be completing somewhere between 17 plus minus 3, right? If you take the 1 standard deviation, if it's 2 it will further increase, but if at 1 standard deviation, right, at 1 standard deviation, a project is likely to complete within the range of 17 plus minus 3. So it is basically means it may complete between 14, right, to 20 days. This is what it's mean. Now since it has a standard deviation, so definitely we need to understand the probability aspects, right? So what is probability of completion of the schedule within 17 days? What is the probability of completion of the schedule within 14 days, within 20 days, or within, let's say, 21 days, or more than that, let's say 30 days? So how do we calculate this probability? So remember, we have calculated this standard deviation. We'll utilize this standard deviation and calculate the z value, and we'll take that z value to our probability distribution chart, and from there we will find out our probability, right? And this way you can utilize to calculate the probability of completion of any project. So previously we have calculated our critical path, right? This is our critical path network. So we identify our critical path as 1 to 3, 3 to 5, and then 5 to 6, right? So this was our critical path, right? 1 to 3, 3 to 5, 5 to 6. Now against that we have calculated our variance, right? And then there was 9, and then according to the standard deviation it was 3. Okay, so now we are utilizing the standard deviation, we can calculate our z value, right? So z value formula is simply a ts minus t as the estimated, which is your estimated as per your critical path, right? What is the path which you are getting, and then divide by your standard deviation, which is basically 3, right, which we have calculated from our PERT technique. Okay, so now we utilize this z value, and then we'll calculate our the probability. So if you see here, let's say we want to find what is the probability for completing a project within 13 days. So we will apply this formula. 13 minus 17 is our which is coming from a critical path, right? Then we have a standard deviation, and if you see here, if you go here, and then we see the z value is basically your minus 1.3, which basically correspond to around 9.18% of the probability. If you see here this value, right, so if you just calculate at 21 days, your z value will be 1.3, which correspond to your 90.8% probability. Okay, so if you see here, even though we are taking 21 days, okay, even though we are taking 21 days, which is more than your 4 days more than your critical path duration, right, which is your 17, still the probability of completion is 90.8%, right? So it means that increasing the duration doesn't mean that your project will be 100% completed as you expect, right? So there's always probability, and that's why we utilize a PERT technique to estimate the probability, to find out those ranges and the the confidence estimate under which we can estimate those durations. So this is how we utilize the PERT technique to calculate the probability of completion of the project given a certain duration, as well as finding your critical path.
Also, while drawing the CPM network, you might face an issue where you don't get a converging point for the preceding activity, and you need to start an activity from those convergence point. So to solve this kind of problem, you may be needing a dummy activity to draw your CPM network. And to demonstrate that concept, let's learn our next session that how you can utilize a dummy activity while drawing your CPM network.
So far we have worked with events, where the predecessors were converging at a single point. So from there you can branch out your preceding activity. Now what if there is a relationship where the preceding activity are not converging at the same node, and then you need to how you will represent those activity in a network diagram, and how you will basically convert those network diagram by utilizing some dummy activity, and then calculate your critical path. So dummy activity, if you see, they are just an activity without a duration for representing a relationship. This is what is mean by that. They are just only for representing a relationship. There is no actual duration added to those dummy activity, right? So if you see here for this diagram, so here if you can see the relationship between 3 and 4 is actually what is called a dummy activity relationship, and its duration is actually 0. So it's a 0 duration, but it's just showing for the relationship that the activity 2 and 4 are completed, and then they can move with this one, the 4 3. So if you see here, this is how you represent your dummy activity, right? And the activity between the nodes do not have any, basically what it says that do not have value means no have no duration, right? Now the network should have unique starting and ending node, that I think that we know from already, right? And here one thing you will notice that while you're drawing dummy activity, you need to understand that no activity can be represented more than a single arc, right? That's important, which we will see in our example, that how the two are various possibility when you have the there's non-converging preceding events, and how you can converge it through utilizing the dummy activity, right? Then this we will be seeing that example there. Then the no two activity can have the same starting and ending point. That's also very important, that one activity cannot have the same starting or same ending point, right? It has to have a different points where they can form a network. So we will be seeing all those points when we see the example, so that it will be better more clear to you how to utilize the dummy activity. So let's take several example and understand how you can utilize the dummy activity to correctly draw your network diagram. So let's start with example. So here we have given this activity. This is immediate predecessor relationship, and then this is the duration, right? So if you start, let's say this is node 1, right? Now if you start with node 1, let's say you start your activity, A and B are actually starting from node 1, right? So there is no predecessor. So let's say this is node 2 and this is a node 3, and this represents your activity. Oh sorry, I think I made a mistake, right? No, that's right. We should just change it. This is activity A, not B, and this is activity B, right? So now once you reach node 2, you can see your next preceding activity C and D, right? And C and D are starting when A and B are finishing. But if you see, there is no a single node which represent A and B converging, right? They're not converging at same point. So to show that relationship, that converging relationship, you need to draw this dotted line, which basically represents that A and B are converging here, right? And then you can start from here, C, right? And then D. So now through this dummy activity, this is basically your dummy relationship. Let me just mention it, dummy, or you can just denote it by, let's say, C1, right? I just mentioned dummy here, and then you can, let's say this is N3. Oh sorry, N3 we have used already, right? So let's say this is N4 and this is N5. So for N3 you will be having, let's say this is your C and this is your D, and then you have the activity B, right, which is starting, sorry, activity E, which is starting after B. So let's draw it like this, right? This is your activity E, and then let's say N4, N5, and 6. This is node 6. Okay, So we have completed E also. Now let's move to F. Now F is starting after C, right? So we'll just what was that? N7. Okay, and this is your F. And then your, if you see, F is also starting after C, but then F and G are converging at same point, right? And if you see, G is starting at D. It means if F is ending here, so your G should be connected with this, right? Because we have a common node where F and G are ending, so this should be your G, right, where F and G are converging. So from here, if you see, we have drawn F, G. Now H has to be drawn. Now H will come out from F and I will also come out from F and G. So from this node, these two activities will emerge. But if you see here, for J, you need to have an activity where E and H are getting converging, right? So it means that you have to, this H, let's take out H here, and when you draw H, you need to just make sure it is there, and this should be H, right? Why? Because E and H are converging here, right? Remember, so this is your H. Then we have the remaining activity of I and J. It means I and J will be connecting at single node. So I is coming out from F and G. This is F and G, right? This will be your I. Let's denote it as N8, right? And then you have J, which is coming out of your E and H. So it will go here, and this will your J, and this will form your CPM network diagram, right? I'm not going to calculate the critical path, right? We'll be calculating this later. I just want to show you, how to utilize the dummy activity, and then we'll come back and solve this problem with critical path, right? So for the timing, just focus on how we utilize this dummy activity, right, to complete our logical relationship, right? Logical relationship means this immediate predecessor.
So let's draw the network diagram for this question. So let's start with node 1, right? Let's say this is our node 1, and from node 1 we can draw our activity A, right? Let's say this is node 2 and that's another activity A. So activity A can start immediately, right? So we have completed our activity A. Now let's see if activity B and C. Activity B and C are the immediate predecessor. A is the immediate predecessor for this. So it means A and activity B and C can immediately start with node, and this is N2 and this is N3. Okay, let's say this is N4. So we can start our B and C with A as a predecessor activity, so that is also done. Now for D, if you see here, D has to start from C, so D can start from here. But if you see here, D is also converging at a point where E is converging, and E is starting at a point where B and C are converging. So to draw next D, we need to have a point where E is converging. Okay, now to draw the E, you need to have a point where B and C are converging. But if you see, B and C are not converging at the same point, right? So they are different at the two different nodes. So to represent a connecting link between B and C, we need to create a dummy activity, right? Which is your, let's say C1, which is your dummy, right? So now we have the got link for B and C. So from this B and C, we can draw our E as well as D from C from here. so that it converges at same point. So your E will be like this, right? Let's say this is your E. Let's draw this as node 5, and then if you see here, your D is also getting converging here. Okay, so this is your D. Then what you will have to draw is your F. F is again starting from ED, so that you can straight away draw, right? This is your F activity, node 6, and then your G is starting after that F, so you can just draw G activity. Let's call it node 7. Okay, now you can see H can start immediately from your starting, right? There is no predecessor, so it can start from node 1. Okay, let's draw like this, and let's keep it for the time being, node 8 and H. Okay, now if you see for I is basically starting at a point where F and H is converging. Now F point is here, H is ending here, right? So it means we need to have a dummy activity to connect this and link it. So this is F and H now are connected with this link. From here we can start I, which is their preceding activity, and then converge to node 8, and this completes our network diagram. Okay, so this is how you will be utilizing activities, dummy activities, right? C2 is your basically dummy activities to draw a network diagram. So we will utilize C1 and C2 as dummy activity to network diagram. So let's draw the CPM network for this question. So, and here also we will be utilizing the dummy activities for our network. So if you see here, again we can start our activity node A without any predecessor, so we can just make it node 1, and we can start our activity A, right? Let's call it node 2, and this activity A is done, right? Now if you have see the activity B and C can start immediately, right? B and C can start immediately. If you see B and C, let's put B and C, and let's say this is node 3, this is node 4, and can start, right? But if you see here, to start D you need to have B and C at same node, right? It means again we need to use a dummy activity to connect the B and C, right? So your D activity can start from this node B, right? And let's put it here. B and C, this is your D, right? So let's set this node 5. Okay, I forgot to put the arrow. So now we have the activity D is also drawn, right, which is coming out to B and C. Now you need E. Okay, E need to be drawn from D, so that we can do node 6, and then that's your E. Okay, then your F has to go out from E, then G also need to go out from H, and then H also need to come out from E. So let's draw like this. So you can have 3 activity, and let's draw, this is what, node 7, node 8, and let's say node 9, right? So it just represents E, F, G and H, right? Now if you see here, your activity I is starting from a common point FGH. Now FGH are three separate activities nodes. Okay, so they are not converging at common point. So what we will do to converge this point at same node, we need to draw a node here. So let's converge them at common node through this dummy activity and through this dummy activity. So we will utilize two dummy activity and then converge it at node 8. So now at node 8 F, G, H are converging. Okay, from there we can draw network or activity I, and we can end this with, let's say, node 10. Okay, so here we utilize three dummies activities, right? Three dummy activities to complete our network, right? And one more thing also, if you see, for any critical path for this network, your D, E and I will always be there, right? Because they are this connecting link to this network, right? Whatever network you follow, your critical path has to be D, E and I. So in case if you have multiple choice question, you can immediately find out the correct answer, or at least you can remove the wrong answers from the multiple choice. So this is how you utilize dummy activity to draw your network. And then after drawing network, you can simply follow the same process what we followed earlier to find out the forward put the durations and then find out your early start and late completion through forward pass and backward pass, and then you can find out the critical path and project durations. So this is how you will utilize dummy activity to draw a network path and then solve your critical path method solution. So now let's remember we have drawn this CPM network earlier, right? And now let's try to calculate the critical path by utilizing this duration. So remember we are following this nomenclature here for early start upper box and then the lead completion for low. So we'll start for this network diagram. So we can start from 0, right? And then 0 plus 4 is your 4, and then we can see we have the dummy activity here. So 4 plus 0, it should be 4. Then here 0 plus 3 is 3, so basically it should be your 4 because 4 is higher here. Then 4 plus 2 is a 6, right? And then here 4 plus 4, 9. Okay, if you go to the next node, node 6, 4 plus 6 is your 10, right? And then but if you see, let's check if here we are getting from what value we are getting from this node, because this node is coming from n7, this row is coming from n7. So 6 plus 4 is your 10, right? And then here if you see 9 plus 3 is 12, so actually it should not be 10, it should be your 12. Okay, so it should be a 12 because 9 plus 3 is 12. Now if you see 12 plus 7, so this is 19 if we follow this path, right? But if we follow this path, it was coming as 10, so obviously it will be 19, not 10. Okay, then we move to this path from 19 plus 2, this is 21. If we go from this part, 12 plus 4, it is 16, so 21 is higher, so we'll take 21, right? Now we'll follow the reverse. Okay, so reverse again, 21 is, sorry, so here go keep 21. Okay, now from 21 we do the reverse calculation, 21 minus 4, so again here we can see 17. Okay, so let's type 17 here, and then 21 minus 2, again it's 19, right? And then if we, but again here we need to see one more thing, So here, from here we are getting 17, fine. But if we follow, remember here two rows or two arrows are coming out. So we'll take first this 19 minus 7, then it's 12 is coming from this path and 17 is coming from this path. So basically 12 is lower than 17. That means we need to take 12. 12 is the lowest, right? We are doing the reverse path, right? Then again we move to 12 minus 4. Okay, then here we will be coming as, you know, the 8. Okay, and here 12 minus 3, again 9. And then we'll further go here, 19 minus 6, 13. Okay, then again here we have the dummy activity, which is, you know, if you see here, so 4 minus 0 is coming basically 4. So we will take 4 here. 9 minus 5, 4. 8 minus 2, 6. So 4, we will take the lowest one, followed by n 5 and 2. And then 4 minus 4 is again 0, and here if we say 4 minus 3, it's coming 1, so we'll take the lowest, which is 0. So this is our critical path, you know, network diagram. Now if we try to identify what are the critical path here, right? So if you see here, from node 1 to node 2, right, that's one path where we can see the load ES and LC are equal. So basically here, 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 and these are the nodes, you know, where we have the LC and ES are equal. So we'll choose first this one. Then this is dummy activity, so we'll go here, right? Okay, and then from there we can go there, right? And then from there we have now two options. Either we can directly go here, okay, or we can go here and then go there, right? So let's first go here and then go there. So this is our first path. So if you see, the path 1 is what, basically your node 1 to node 2, right, to node 5 to node 7 to node 6 to node 8. Okay, this is your path 1. Now for node 1 to node 8, the durations or the activities are basically A to D to G to H to J. Okay, these are the activity. Let's take the and if you see the durations, so it is basically 4 plus D is 5 plus G is your 3 plus H is your 7 plus J is your 2. Okay, so which basically 21 days. Now if you see the part 2, let's draw the part 2 by some other color. Okay, so part 2 will be what, right? It will again start from here, right? We'll go here and then we'll come here. Now here we are having two options. So first option we have already taken. Now we can go here and then reach to the node 8, right? So in this path 2, if you see, it's taking node 1 to node 2 to node 5 to node 7 to node 6 to node 8. Okay, so let's take those activity A to D to G to, sorry, now to, instead of going H, let's take just I. Okay, now we see the duration, it is 4 plus 5 plus 3 plus I duration is 4, so which is basically 9 plus 3 12, 12 plus 4 16, this is 16. Now we have the two critical path, right? One is path 1, another is path 2. Which ones to choose? So critical path is, always remember, critical path is the longest path of the network diagram. So if you see here, path 1 is your longest, and which is giving you the duration of 21, right? And this is what your duration, which you calculated as late completion equal to ES. right, of last node. Remember this. Okay, this is last node, and late completion or list start duration is the same as your project duration. So you should be taking this path as a critical path, even though we have several critical paths, but the longest critical path is your actual the project duration, which you should be considering. Okay, so this is how you choose, utilize the dummy activity. If you have a multiple path, then which path you to choose. And suppose if you don't have the fixed duration, there is uncertainty in the duration, you can utilize a PERT technique to calculate the duration, and then utilize your variability factors there, and you can calculate the probability of completion of a project in a given duration. So have you ever wondered why the critical word is utilized in critical path method? Why not serious? Why not captious? Or why not another synonym word? Why we especially use the critical word in CPM method? So if you ever wonder why we utilize a critical term in CPM, right? So if you see, the CPM is basically taking the term critical, okay? And why we utilize critical, why we don't use serious, or why we don't use another synonyms? Well, if you see the history, so the nuclear bomb, it was a project which was during which your critical path method was developed. Also, the PERT was developed for the nuclear submarine for Navy special project. Now, what happens if you see here in nuclear engineering, the critical mass is a common term, and it's very important, right? Because it's a mass which is smallest amount of fissile material which need to sustain your nuclear chain reaction, right? So if you see in nuclear engineering, critical is very common and very important term utilized again and again, and right, and this was the reason the critical word was picked up in critical path method. Now, after you learn this basic concept of CPM and PERT technique, you will be wondering how these techniques are used in professional world, how these techniques and concepts are utilizing solving your actual problem or actual project while you're working in your office environment. And this is what we are going to learn in briefly, that how these techniques are utilized, and we'll try to correlate whatever concept you have learned earlier in terms of solved example, how they are actually translated while you're working on a project. So if we talk about how the professionally we utilize the CPM, or how do we apply the CPM techniques in professional projects, so it basically consists of 6 steps, and these are all those steps we conceptually learn while we were solving various CPM network problems. And but the thing is that this concept has to be applied and professionally in a very large scale, in a very professional manner, because remember, every project is unique, and you cannot simply use some list of activity which we are solving a problem, and then utilize some duration and calculate a critical path method network. Well, in terms of concept, it's fine, but when you talk in terms of practicability or in terms of application of this tool on a real project, it's required a lot more effort than just simply having a CPM network calculation. So if we talk especially in terms of process or in terms of steps which is required to complete this CPM, it's all started with identifying your activity based on WBS, right? So WBS is basically work breakdown structure, and you need to identify all those activities. And remember, it's not an easy task for a project. You have to go through all the project detail, all the scope of work, all the requirement, and then understand what are the activities which is required to be done to attain those objectives. And for those, you may need some subject matter experts, you may need to connect with various people, various function, various organization. It may depends upon type of the work and complexity, which will basically define how much effort is required to identify those activity, and then you need to group those activity in a certain WBS. Accordingly, you need to plan your cost, your further other things which will be aligning with this activity. So step one is identifying your activity, and remember, while we are solving the problem, we were getting like 10 to 15 activities just to solve a problem. But in real world, these activity can go to 2,000 to 4,000, even 10,000 activity. You can see it depending on type of the project. Let's say you have the $1 billion project, right? Now these projects will be having maybe 10,000 or 20,000 activity, or even more than that. Their sequence or their group, and also plan over maybe 4 or 5 years. So planning those all activities, it's not an easy task. It's a huge task. Probably you'll find in corporate world there's a dedicated team assigned to do this activity, right? Then the next step is to identify the dependence. Remember, we've discussed with the various preceding activity or succeeding the activity which should be completed before starting any activity. So we have a separate column where we mark all logics that which activity should finish before some activity start. Now in the real world, identifying those logics require a lot more effort, right? It's required the expertise, it's required subject matter expert who can tell you which activity has to be done when it has to be started, which activity should be completed, what are the deliverables required at the end of each activity. Those all things are pretty complex thing in professional world, and this has to be done as a next step, right? So once you identify activity, the next step is that you identify which activity related to which one and how they are interconnected with each other. Basically you need to develop all the logics, and then so that you can draw your CPM network. Then they create the network diagram, right? Now creating a network diagram, if you want to do manually, I mean we did manually solve various problems for 15-20 activity, that is fine, right? We can do that manually and then calculate a CPM network. But in professional world it is not done manually, right? Because doing a network diagram for, let's say, 10,000 activity, it's kind of impossible task. Or even doing this, it can be done with given resources and the number of the people required as well as time, but then it become it's not effective, or it's not cost effective at least, right? So to do this activity, instead of doing manually, in professional world we use various softwares, right? There are various scheduling software, there are various planning softwares like P6, Microsoft Project. There are several other projects which is available, which helps you to quickly, once you decide this dependency and then the list of activity, you can create the network diagram. In fact, the program will do it for you by utilizing this CPM and Pert technique, right? This is what these techniques are basically inbuilt, coded in the program, and they will basically help you at the back end of the software to create this network diagram. Then the next step is to create your or estimate your duration. Again, here your Pert will come very handy, because as I told earlier, right, in professional world, when you do the practical project, you will never know what exactly the duration of each activity, how much time is going to take to complete that, right? And that's what the Pert will help here. And again, this all can be done through the software. There are softwares available which can help you do this job quickly and efficiently rather than doing it manually, right? And then again, of course, you calculate path. This also happens in software. You don't need to do manually. There are again same software, P6 MXP. There are several scheduling and planning software available which will basically develop your critical path. And then step 6 is determine the float. Of course, this will be one of the output of your software. Software will tell you, right? In fact, this is also your output, this is also your output. You can get it from the software or the planning software, right? Planning software will help you to get this output. So the point is that once you get these floats, when I say the float is your total float, free float, how to utilize those floats. These are the critical information for any business to understand which activity can be delayed, which activity cannot be delayed, which activity need to be focused to make various business decisions, right? Because remember, a project has to be completed within a given timeline, so it has a fixed timeline. Also, the project is given a fixed budget, right? It cannot have the infinite resources, it cannot have the infinite money to go on. Okay, so it's become very important to understand while working on a project which activity to focus, which activity to delay, which activity you cannot delay, and these all basically done through identifying your flows, right, against each activity. So that's why it's become very one of the critical input and one of the key tool to make various scheduling or planning decision by identifying what is your float available. So as we were talking about the float and slack, so slack or float are basically same. So a float means basically task, how much it can be delayed, right? And a task is, when a task is delayed, it can have two impact, right? Either it will impact the subsequent activity which is going to complete after the task, or it will impact the total float, or maybe there may be case that it impacts both. It impacts the task as well as impacts the total project float itself. Here one thing you should notice that any activity which is on your critical path will always have zero float. It means you cannot delay those activity. So the activity on critical path cannot be delayed, and that's what the purpose of this critical path method, to identify those activity where you should be cautious or be focused so that you don't impact your project schedule completion. Also, other activity, when I say other activity, means basically these are non-critical activities. So these activities can be delayed depending upon whether you have the resource available, whether you want to divert some resources and delaying some activity. So here you can manage those activity without impacting, or without impacting the completion of the project or project deadline. So while dealing project professionally or the project in various industry, there will be the issues which you will be arriving, right? There will be some uncertainty because projects work in a very dynamic environment. There's a lot of factors which is uncertain, and when it's occur, this impacts your projects, right? And so to solve those problems or to deal with those problems, basically two approach are followed, right? Mainly fast tracking. So fast tracking means, let's say you want to complete a project earlier, or let's say you say that some resource was not available and now you want to complete that activity. So what you will do, you will do this activity in parallel. So let's say you have started some activity like this in sequence, right? That you will first do this activity, then you will do this, or then you will move to activity C. So instead of doing step by step, what you can do, you can parallelly start this activity A, B and C from here, right? What will happen, this process is basically known as your fast tracking. So you, instead of waiting activity to start after this step, you start all of them together and try to complete at once, right? So this is what is mean by the fast tracking. You run the multiple activity of the critical path in parallel, but you cannot start those activity which have dependency, right? You can only start those activity which are not dependent to other for starting, and you can do those activity in parallelly so that you can manage your resources better, right? This is a one technique which you can utilize when you need to manage your activity or manage your project completion duration, depending upon how you want to manage it. So of course it's require additional resources. So basically it means that your resources are available and you have planned it for some later duration and you can do it parallelly. Also you need to focus on the quality, because there may be the point where the resource is working or was supposed to work on another project, and when you decide as a project manager that the project had to start parallelly, then you need to make sure that the quality of the work remains same, right? And the quality has to be controlled there. So good resource management is key here while you utilizing your fast tracking techniques, right? So make sure whenever you're doing fast tracking, you focus on the good resource management. For dealing with contingency, there's another technique that is called crashing, right? So crashing is basically, if you need to rush activity, what you will do, you will remove some resources from one activity, right? Let's say there were 10 engineers who were supposed to work in this activity B, A, and let's say A, B, C, this activity here, 3 resources and 4 resources. And in case if you want to complete all those activity, and then so what you will do, you will move some resources from here to here, and then maybe from here to here. So what you're trying to do, you're moving the resources from various activity and putting on and one focus activity to complete that too, in case if it's required, right? So that's what the process is called, crashing. You take out the resources and put it on a particular activity to complete that activity. Now this is not recommended. Why? Because it disturbs the balance between your resource distribution, and also its impact both. Some activities are critical, some are non-critical. It can impact your both critical and non-critical activity, and then that will lead to the either delaying your project or increasing the budget. So it's not recommended, but yeah, in some cases, some emergency cases, it's required. Let's say your project completion is nearing and you are exposed to the LD. You need to focus on the completion of particular activity at all costs so that you avoid the LD. In that case, you can go for those crashing technique, then on those extreme and emergency situation only. Otherwise, in general, crashing is not recommended, right? Because it's impact activity both critical and non-critical, means activity which is on critical path as well as activity which is on non-critical path, because it's directly take away the resources from various activity. So one last point which I want to discuss, that why you should also monitor the non-critical task, right? The CPM is basically identifying your critical task. But the point is that when you're completing a project, it's combined both, right? Critical and non-critical tasks. And if you only focus on critical tasks, at some point of time, in case if you're focused on the critical one and not worried about the non-critical task, those tasks can become critical. Because remember, by doing just critical tasks, you cannot complete the project. You have to complete both non-critical and critical tasks so that you complete the project. So it's very important, even though the non-critical tasks are not urgent for that particular point of time, but they may become critical depending upon if those activities are not completed, or there's no focus on those activities, or those activities are delayed. You might think that I have a float, then I can work on those activities later, and later on you realize is you have no more time to further delay those activity, or you cannot you have to start those activity. In this case, that becomes becomes the part of the critical path. And this is how many times or several times in professional what happens, that people delay the activity, and at some point of time those activity become critical. So it's very important to focus or keep track of those critical as well as non-critical activities, so that you are able to manage the floats and manage the project completion and meet the project goals and as well as deadlines. And this marks the completion of this course. And in case if you like this video, please hit the subscribe and like button so that we can bring the more video for you like this. Also, in case you have any comment, please use the comment section so that our team can reach and help your